Hello everyone, welcome to infyGyan in this very exciting video of exponential equations. Here we will solve one exponential equation, that is x power x equal to x power x power 2. We will solve this exponential equation using algebra by two methods, using logarithmic, and then we will solve using a power b equal to 1 form. Then we will see the graphical analysis part. We will conclude something. If I will ask you, parabola have one turning point, either minima or maxima, but line doesn't have. This part we will talk about in graphical section. Okay, so let's get started by writing one exponent property, that is a raised to the power b equal to a raised to the power c. Then we can conclude b equal to c. Okay, so x power x will be equal to x power 2. Now we can take log both sides. So let's take log. Now one property of logarithmic will come into the picture, that is log a power m can be written as m log a. So I will write x log x equal to 2 log x. Take all the term to the left side. So log x will be common out. X minus 2 log x is equal to 0. Okay, now either x minus 2 will be 0 or log x will be 0. So once you are taking log, that means x is positive, non-zero it is, or you can write x positive. Here x cannot be negative, x must be positive. Okay, so from equation 1, x minus 2 equal to 0, x will come out 2. We can check, we can predict also, this is our solution. And log x is equal to 2, that means x is equal to 10 raised to the power 0, that means 1. So x is equal to 1. Let's check the solutions. We will find out, we will calculate. Let's x equal to 1. So value will be 1 raised to the power 1 raised to the power 1 equal to 1 raised to the power 1 raised to the power 2. So 1 raised to the power 1 is equal to 1. So 1 power 1 equal to 1 power 1. So 1 equal to 1. That means x is equal to true. 1 is true solution. Now 2. You will write 2 raised to the power 2 raised to the power 2 equal to 2 raised to the power 2 raised to the power 2, which is equal. So x is equal to 2 is also one true solution. So there are basically two solutions, 1 and 2. That's it, using log. Now come to a power b equal to 1 form. I will write x power x. So we'll consider like this, x power 2. So let's write this x power by the same exponent property. I will write x square is equal to x power x square, or I will, because of I will multiply, then I will write 2x. Divide both sides, as x cannot be equal to 0. So divide both sides by x power 2x. So that value will be x power 2 divided by x power 2x equal to 1. Now x power a over x power b can be written as x power a minus b. So I will write this equation as x power x square minus 2x equal to 1. This is our standard a power b equal to 1 form. Let's write that form, a raised to the power b equal to 1. So there are three conditions. First is a equal to 1, b should be real, its power. Second point, B can be 0. If anything having power 0, that will be value 1. But one more condition is there, that is A should not be equal to 0. Third condition is A is minus 1 and its power should be even. Okay, this is even. Okay, so our A is x. This is what? A, and x square minus 2x is B. So let's write three conditions. So first condition is x is equal to 1, base is 1, move from here. Okay, and B should be real for that value. So B means power. X square minus 2x belongs to real number. So okay, let's check. 1 square minus 2 into 1. So that value is 1 minus 2, so minus 1, which is real number. So that means x equal to 1 is your true solution. Done. Second case, B equal to 0. So I will write x square minus 2x equal to 0. Okay, and A non-zero. So x is not 0. X take common, x minus 2 equal to 0. So here you will get two solutions, either x0 or 2. But condition is x cannot be 0. So 0 will be rejected. What solution is left? That is your solution of the final equation, that is x is equal to 2. Now third case. Third case is x is equal to minus 1 when x square minus 2x should be even. This value should be even. Let's check. Minus 1 whole square minus 2 times minus 1. So if you will check, this value is 1 plus 2, which is 3, and it is not even. Hence, we will reject x equal to minus 1 solution. So by this method, this form is called a power b equal to 1 form. So by this method also, x is equal to 1 and 2 are the solutions of the exponential equation. Okay. Now come to graphical part. This is something very, very interesting. My question to you is x power x equal to x power 2. If I will write the property of exponent, then I can write any time x power x is equal to x power 2. How? Just take the product, x into x, that means it is x power x square. So graphs are different. You can see this red color graph is, this graph is for x power x. And this blue color graph is, I have zoomed actually, that are actually separate lines. X power 2. One important point is, here you are not having any turning point. No turning point means your graph is monotonic throughout increasing function. For defined domain I am talking about. You will see there is no minima, no maxima, straight away it will monotonic increasing. Once you raise the value of x, you will get only monotonic increasing function. Now come to the second equation, second graph. If you will see that graph, then that graph is attaining minima, then it is raising its peak. Means it is going towards infinity after attaining minima. That means function is having one turning point. And if you will see the functions actually, x power x equal to x power 2. So if I will apply the exponential property, it will come same. So but graphs are not same. So what is the difference between, once you apply the property, once you apply that property, a par b par c, a par bc in this exponential form, then it will give you x par x square. It is changing its behavior. Now it is parabola, parabolic exponential equation or parabolic exponential function. Here you will say this is like a line. You can see it is like a line, only monotonic increasing function. This question, and if I am talking to you y equal to x line, y equal to x square line graph, y equal to x square, then in case of y equal to x square you are attaining minimum. After that you are getting maximum, means maximum value towards infinity the graph will tend. But in case of y equal to x, there is only one behavior, that is monotonic increasing. So this is the conceptual difference, because parabola having one turning point, line doesn't have any turning point. That is why it is having a starting point from origin, and second one x par 2 having the starting point at value, but it is attaining minima, then it is reaching towards infinity. This is the conceptual point. And see, there are two solutions, x is equal to 2 and x is equal to 1, which we already proved through algebra. I hope you like this video. Thank you so much for watching. Please do subscribe my channel.